Hello, everyone. My name is Ryan Janssen, and I've deputized my co-founder and CTO, Paul Blankley. You there, Paul?
How's it going?
And today we're going to be talking about building a data stack in 2021. Thanks for listening, everyone. It's really exciting to be here. Both Paul and I are in fact Canadian, but we're not in Toronto at the moment, but it's near and dear to our hearts. So let's just jump right into it, I'd say. I mean, the very first thing we need to talk about is like there's been this sort of resurgence and a renaissance in how analytics has happened over the past few years. It's been exciting. After a couple of false starts, we're sort of landing on a really successful paradigm for performing analytics and business intelligence and ultimately deploying artificial intelligence called the modern data stack. And this is something you're going to hear us mentioned a bunch of times. You probably heard it before, modern data stack. It's a powerful tool. It's great because it's a highly extensible, very flexible, very powerful, very fast set of tools for performing all of the above, often in near real time. Now the challenge is that there's been this explosion of tools. It's like a Cambrian explosion of tools, basically. And this is Matt Turk's latest data and AI landscape. In 2012, he had, there's a few dozen on there, and now there's this enormous set of tools that you can choose from. Now, a select few in this gigantic list are actually, part of the modern data stack. But there's tools for everything now, and it's, the challenges for CIOs and CTOs and engineering managers now is sort of knowing which tools are the important ones and which ones are still maturing or still developing. And we're hoping to demystify some of that today. Maybe Paul and I can talk a little bit about ourselves too here. Before that, let's just here's our questions. Right, here's what we're going to discuss. What is the modern data stack? Why do we want to have a modern data stack? Why am I not using Hadoop anymore? What can I do with it? Which tools? And why there's so many damn flowcharts? I guess we're going to try and answer all of these questions throughout the course of the next 45 minutes or so. And the plan is that we're going to run through a bunch of these. Like I said, it'll take 30 to 45 minutes in total. Paul and I are just going to riff on a bunch of the tools, basically. Please jump in with questions in the chat at any time. Paul's monitoring the chat, and he's going to jump in and sort of say, hey, we have a question. We're also going to pause periodically after some couple key moments and just see if there's any questions from the audience. Next up is this quick thing about, there's about me on here. I'm incredibly egocentric, so I don't have about Paul on here either. But we're basically have a lot in common. We're both data scientists. We're the co-founders of a company called Zenlytic, which is an analytics tool for e-commerce and D2C brands. We're not going to talk too much about Zenlytic because the goal of this workshop is to introduce you to sort of the common denominator tools. But Zenlytic is a tool that basically lets you ask sort of deeper questions of your data. You can answer sort of the why questions automatically instead of the what questions. So for example, a dashboard is very good at saying, what did my sales do last quarter? Zenlytic can say, why did my sales go down 15% last quarter? Before founding Zenlytic, I was a VC myself. In fact, you can catch me at the fundraising panel later on today. I was a strategy consultant and I was an engineer. So I've kind of sat immediately to the left and right of like the data producer, data consumer gap here. And I think I have a good handle on both sides of it, which is why I like to talk about this. Paul, would you like to introduce yourself as well?
Yeah, definitely. So I'm, like Ryan said, my background is data science, but I've been working in modern data stack stuff basically since it came to be about as prevalent as it is. So as part of Zenlytic, we've set up several of these data stacks for companies and sort of overseen them life cycle wise from like creation of, we have a problem, we need to create this data stack, to like, okay, how do we maintain this thing and actually get it to consistently deliver results we need? So I've sort of seen a lot of this data lifecycle and have a lot of opinions on which tools are good and which tools you should run away from. So you'll hear a lot of that throughout this presentation.
Yeah, and there may even be some small differences between Paul and I in those tools, which is probably going to be really exciting. wanted to shout. But I will say, out of the two of us, Paul is the more technical as well. So Paul is more hands-on keyboard than I am these days. He's intimately familiar with deployment and maintenance of these tools. So in the event of a disagreement, we're going to defer to Paul's more expert opinion than mine too. So without further ado, let's just jump right into it. Here's a flowchart that we stole off of the internet from a company called Indicative. Now, there's a lot of charts like this that kind of try and outline schematically what the modern data stack looks like. They vary a little bit from stack to stack, and they're almost always done by someone in this giant list of tool providers. They're almost always done by one of these companies, and that company inevitably has their logo show up somewhere in a very prominent spot in the flowchart, as we have here. That notwithstanding, this is actually a pretty good sort of, first start of what a modern data stack looks like. We're going to spend a bunch of time going through. We're going to look at some of these boxes in detail. We're going to make a couple changes as we go along as well. But starting just from a really high level, basically. And I'm not sure, can you see my mouse, Paul?
Mouse? I cannot see your mouse.
Okay, so. All right. Well, I don't see a laser pointer here, so I'm just going to dictate. Generally speaking, what we have here is a schematic for what the modern data stack looks like. It's generally, one or more of these tools are deployed from each box and orchestrated together to deliver an end-to-end sort of BI and analytics solution. And it starts down in the bottom left, with third-party platforms, and the top left with actions from the website. And we flow to the right, all the way to the data consumers. And basically what the modern data stack is it's a set of tools for, making all of these pipelines stay up reliably. Some of the unique things about the modern data stack is one commonality you'll see here is the majority of these tools are actually configurable as code. So for example, DBT, which we're going to spend a fair bit of time on, it handles all your data transformations. It actually lets you write all of those transformations in a relatively simple scripting language. Generally, the lingua franca is SQL and Python, and store those basically as text files. And that configuration is really powerful because it helps analytics engineers think more like software engineers. It lets you, check your code in and out of Git. It lets you do version control. It gives you a historical record of what was being done when. So, all of those software engineering best practices can be done with the majority of these tools, and that's one of the biggest strengths. Another strength and weakness of the modern data stack is the diversity of tools that we have here. So as you can see, there's lots of different tools for different purposes. That's great because it makes things very extensible. If let's just say that you don't want to do customer analytics, okay, don't install them to the mix panel. You have your wealth of choices for just about every step in the stack as well. Now that's both an advantage and a disadvantage because it requires a bigger understanding of which tools are what, or which tools do what, which ones are good, and every new tool you add is a new interface. So there's risk for something breaking or risk for something being configured poorly. There's a lot of discussion right now in the analytics community of what parts of these are going to consolidate, and I think it's likely over the next several years we're going to start seeing chunks of the stack consolidate together. But it's also an advantage for having that sort of flexibility. So let's go through and make some changes. I'll just stop there and see if Paul has any other comments generally on the modern data stack or anything that you feel is important to add here too, Paul.
Yeah, I think the one thing that's missing from this is that in most environments you have some sort of production database. That production database will go through like Fivetran or Stitch or whatever thing you pick for ELT at the bottom. So that's third-party platforms plus any other like databases you need to add. So just to hopefully add some context there. But other than that, yeah, I think this is a good overview of the different flows.
Yeah, excellent point. And a central element of that is the big one in the middle, the data warehouse, which is an essential part of the modern data stack. They call it a data warehouse here. It's an analytics data warehouse. So this will be separate from your production databases. The reason for that is, of course, that you can run big, beefy stuff on that data warehouse that maybe makes the lights dim a little bit, and it doesn't interrupt your production workflows. So if those are in the same warehouse and you lock up your data warehouse with a bunch of compute, maybe you're not serving things to your users at that time, for example. So the separation of those is important. Great point, Paul. All right, so let's make some changes. So the first thing we're going to do, there we go. We already have this. Standardized modular engineering best practices. One thing we actually didn't talk about is speed, actually, which is a great sort of element of the modern data stack. When Paul and I started doing this, doing Zenlytic a couple of years ago, this stack hadn't really evolved yet, and I think we've probably seen an order of magnitude change, or at least close to it, in the speed that these insights can be delivered. That's driven by better hardware, better warehousing. A big part of that gain is actually happening from advances in that data warehouse part of the stack. So Snowflake, for example, is really, really, really fast, and there's even other warehouses nipping at its heels, such as Firebolt, who claim to be even faster. And that's just clutch. I mean, the value of analytics is in the timeliness. So delivering those in real time or near real time, super important and kind of a watershed moment for analytics, frankly. We covered this as well. So without further ado, let's make some more changes to this data stack and look at some of these pieces one at a time, basically. So first thing we're going to do is get rid of that indicative block for now. They're a good tool. I don't know if they deserve their own section on the modern data stack. We're going to put a pin in that, and we're going to use that later on as well, actually. So let's just leave that there for now. And let's start down with these third-party platforms. Now, Paul mentioned this is also your production warehouse. The other thing this could be is API connections. And they mentioned Marketo, HubSpot, Zendesk. Those are all great examples. It's certainly not an exhaustive list, and here's a few other ones that we see frequently. Probably the two most common that Paul and I see are Shopify and Google Analytics. But basically anything with an API that you can access the data is fair game here. The problem right now, of course, is that those data exist in silos. So, if you wanted to sort of compare your Shopify data and your GA data, understand how your website traffic flows through to your purchase conversion rates, for example, you only get part of the picture in each Shopify and Google Analytics. But thanks to modern data stack and the ability to join those, in a cloud native seamless data pipeline, you can finally look across those tools. And Paul, any other ones you'd want to add on to this list, or any comments on third-party platforms?
The only other comment was this can be pretty much anything. So the two tools we had mentioned in ELT here are Stitch and Fivetran, which are the most common ones that you just pay for. There's two open source options as well, which are Airbyte and Meltana. The good thing about the open source options is that if there's anything that's not supported by Fivetran or Stitch that you really need, you can go and, without an insane amount of work, write a connector to be able to go and get that data. So there's hundreds, I think in the 200s now, of different possible connections. So most likely it's already there. And if not, the open source tools are actually getting pretty good for this now.
Yeah, excellent point. And yeah, that's moving on to the sort of ETL ELT section. That is a very good point. Is that the two they mentioned here are the two most popular sort of closed source tools, but growing in popularity are the open source tools. I put an underline here under Fivetran. I don't know if you have any strong opinion on this, Paul. I think they're kind of both pretty good. We see Fivetran a little more often, and I'd say we see Airbyte and Meltana a growing amount now. Is that fair to say?
Mm-hmm. Fivetran's the sort of best-in-class tool for this, but they also charge best-in-class prices. So if you have more money than engineering time, then you should use Fivetran. And if you have too much engineering time left over, then maybe try one of the open source ones. So most people go with Fivetran.
Yeah. Now let's take a quick step back here. We'll talk about this box in a little more detail, ETL, ELT, and what it does. So a big step for ETL, ELT, the reason there's two sets of letters there is that we're seeing a sort of change from ELT, extract, load, and transform, to ETL, extract, transform, and load. And this is essentially the glue that connects those third-party APIs into your data warehouse. These are actually, at least Stitch and Fivetran, are one of the few parts of the stack that aren't necessarily governed as code. These are kind of point-and-click GUIs. But they have sort of pre-built connectors, as Paul says, for generally hundreds of different sort of third-party platforms. that you can do with sort of a one click, and you can say, okay, I want my Shopify data in my data warehouse. You provide creds for both of those, basically a login for Shopify and your warehouse credentials. And this tool goes and, actually hits the API, runs sort of some internal transformations, dumps a, sort of pretty good set of data into the data warehouse. So this is actually when you think of data pipelines, this is probably the biggest pipeliniest part of the entire data stack. And it's kind of the glue that holds it together. Like Paul said, consider open source alternatives as well. Meltano and Airbyte, I think, are the two sort of big open source alternatives there. Yeah, and that's it. These two chunks here actually are a big part of what we call like the data engineering part of the stack, in my opinion. Now, the one other source that I think is important to discuss, which doesn't necessarily flow through the Stitch and Fivetran alternatives, but still ends up in the data warehouse, is the sort of event tracking, consumer usage, product usage tracking elements. These will vary a fair bit depending on your business. If you're running a software business, they're probably very important. If you're not running a software business, you may not use them. You might do some light tracking on your website instead. But what this sort of top left portion of the flowchart does is actually tracking sort of event activity in your website or in your mobile app, for example. People who's clicking on what buttons and the journeys that a user takes through the website, at what point in time they bounce off the website, things like that. Those are all tracked as events and collected through this box labeled data collection and tracking, also commonly known as a CDP, customer data platform. I don't know what that stands for. Is that right, Paul?
That's right.
I think it's customer data platform. There's a bunch of these. I would say that the two most common that we see are Snowplow and Segment, which out of the mParticles being very good, but it's more of an enterprise solution. I suspect Paul will have some interesting thoughts on open source Snowplow versus Segment, and maybe with that segue, I'll let you add any comments you have here as well, Paul.
Yeah, Segment is usually easier for like small teams to get set up with, but it also gets quite pricey later on. So the sort of most commonly recommended one is usually Snowplow, just because it's open source. So if it does get super, super pricey, you can migrate from their hosted solution to hosting it yourself if it just becomes unbearably expensive. Whereas in Segment, that's not an option, and you would have to recreate your entire like tracking infrastructure. So.
And I think in terms of raw numbers, there's actually a lot more Snowplow users than Segment users out there.
Mm-hmm. There's about 150,000-ish people who use Segment, and there's like 1.6 million people who use Snowplow. So Snowplow is like a lot more common. That's according to data with the bill width. For those of you following along at home.
There we go. Cool. And at any rate, the goal of these tools is they take that large number of events and they sort of do a little bit of processing and conversion, and they send it out to one of two places. The first is your data warehouse. That's a great best practice because, again, you're centralizing important information into one place that can be sort of accessed monolithically with whatever tools you want to use and consistently. The other place they can be sent to is to your customer analytics, which is sort of a special subset of BI tools designed for only working with that sort of event type data and making sense of that. They're used for more specific use cases such as tracking conversion. And we're going to come to those later when we get to the data consumption half of the modern data stack. So let's move on to the data warehouse, which is important. This is the most essential part of the modern data stack, frankly. This is the beating heart of your data stack. This is, the philosophy of these data warehouses is everything we said before. It's centralized. You have one place to go for all your information. That gives you many advantages. First, it's faster, right? Because you can handle all your compute monolithically. These warehouses are built to sort of, look inside a data schema and do fast operations on them. It's consistent. You have a single source of truth, and we're seeing this start to emerge really for the first time ever, in my opinion, in the analytics stack, is this is something that, CIOs have talked about for 30 years, having a single source of truth, but we haven't seen the degree of centralization that we're seeing now inside these data warehouses. It's not perfect. There's usually, multiple warehouses and things like that, but the closer you can get to a single warehouse, the closer you can finally get to that, the long-awaited single source of truth. There's three big choices here. I'd say. I don't know if you dispute that, Paul. If you had any other choices this list: Snowflake, the Amazon one, Redshift, Google BigQuery. We see Snowflake a strong majority of the time, and I would say actually growing in popularity as well. I'm sure Paul has a lot of really big thoughts on this, so I will hand off to you to ruminate and wax philosophically on data warehouses.
Yeah, of the warehouses, the only one we have not used is Firebolt, but the main three are like Snowflake, BigQuery, and Redshift. Redshift is not really popular at all. It's also just like harder to maintain, difficult to work with. So the two most common we see, and the two that I'd feel comfortable recommending, are like Snowflake and BigQuery. Of those two, I'm a pretty strong proponent of Snowflake, just because BigQuery can get a little expensive on the back end. But the other thing that's really great about Snowflake is the data sharing. So as companies get bigger, often they have like needs around being able to share data with other parties or receive data from other parties. With Snowflake, that's completely trivial. Whereas with most other warehouses, that's a nightmare. So Snowflake, also performance-wise, Snowflake is the best of these three. So Snowflake, for me, is a clear winner here.
There's also a case to be made, actually, that Snowflake is better for, it has a few more bells and whistles for data consumption. So for all three of these warehouses, they rely heavily on SQL to get the data out. Not exclusively, but they all use SQL extensively. I'd argue that Snowflake's sort of flavor of SQL is a little bit more robust. They've added some more fancy functions in there that actually make it easier to use. Snowflake also, I think, as far as I know, is the only one that has Snowpark, which is they're actually building more robust compute in other languages on top of the warehouse. So I think it's actually only JavaScript right now, but Python is coming. Is that right, Paul? Or is Python out now? Do you know?
It's only Java right now, and then they have some pending support for Scala. It's a very in progress part of the tool.
Yeah. So this is real time news. This is happening as we speak. But it's Snowflake is actually building out these the ability to communicate with the warehouse in sort of more powerful languages than SQL as well. And the other thing to consider too is that, while we're on this, is that Snowflake is a little more robust and a little bit more forward when it comes to sort of custom user-defined functions for accessing the data and running compute within Snowflake. Generally, a little bit easier to access as well. A lot easier to maintain. Just redid their web interface so you can actually make queries on it more easily. Generally, I guess we're all triangulating on Snowflake would be our recommendation for this. This is probably where we'd start. And, it's one of the more important decisions because migrating this is hard. You can bolt off certain tools and bolt on certain tools to the stack, but this is, as we say, a super central part of the data warehouse. Now we're going to do one more step here before we pause for questions as well. And that is this little box in the center bottom that says DBT. This one just gets a big circle. It's the only one on here that has only a single logo in the box. We say if the warehouse is the beating heart of the modern data stack, and DBT is the brain or the lungs or something like that, it's also really important. This is a tool for data transformation. I'd say this is the second most sort of definitional part of the modern data stack. DBT is a tool for taking the raw data that's already in your warehouse, sort of applying some transformations on it, whether they're it could be everything from data cleaning to joining to data munging to preloading certain fields, things like that. and then outputting transformed tables back into the data warehouse. And then those transform tables are usually what power, all of the downstream consumption, or the vast majority of the downstream consumption. dbt is what's enabled a lot of this to happen. Previously, if you were to have a stack like this without dbt, you'd basically have a bunch of sort of disparate scripts that would run that in sort of a haphazard way, and they'd be very brittle. dbt has built-in tools for orchestrating those tables to happen in the right order. It has tools for writing tests and error checking, and it's built to be part of an actual engineering workflow. So it's all of that sort of software engineering best practices applied to data transformations. This is an awesome tool. I'm surprised that it's taken us this long for someone to build a tool like dbt. The vast majority of modern data stacks use dbt, and in fact, you might have heard the term analytics engineer. I think in a large way that's attributed to the use of dbt, and I think that sort of job title originally even started by an analytics engineer is someone who is capable of sort of configuring dbt, and that's expanded a bit, but that's how important dbt is to the modern data stack. Do you have any other comments you wanted to add there, Paul, on dbt or any sort of color?
I would say too, just for context in how this used to be done. This used to be done either like Ryan was saying by like ad hoc SQL scripts, or it was part of the ETL process. So like the ELT process, which is like Stitch or Fivetran, basically just takes all the raw data and just dumps that raw data without changing anything about it into the warehouse. And then you can do your transformations and everything with dbt inside of the warehouse. Whereas previously, all the transformations were done before loading data into the warehouse. So the advantage to doing it raw data and then transformations inside the warehouse means that you have like version controlled, governed, like clear definitions of all the transformations that are happening. And if you need to make a change, you can do that and handle it like a normal sort of software engineering workflow, which means that things can be, fields can be deprecated and then later removed, which means that way less stuff breaks downstream. So the stack as a whole is far less brittle and far easier to maintain. You could, hire a new employee or something, and have an old one leave, and all that institutional knowledge, instead of just being in that person's head about where everything is and what transformations happen, is actually in code in the dbt repo, and just can be learned without an insane amount of work by the new employee. So that's one of the several of the really big benefits of changing the workflow and using the dbt tool.
Yeah. And I can take some comfort that because Paul is the person who maintains our dbt, he is completely replaceable now.
Exactly.
No, so I'm gonna let's pause there for a sec. So this is the first half of the two halves of the stack. Everything we've covered here is the called the data engineering part, the data pipelines. This is everything to get all of your data from a bunch of either sort of disparate API data silos, maybe something that's not even tracked at all on your website, things like that. Getting this giant mess of data into a nice, clean, well-organized sort of set of tables inside a monolithic data warehouse. Everything we've talked to this point, all these tools are doing that. The next part we're going to discuss is the data consumption part, which is what do you do with the data once you have it in there? The benefits are frankly transformational. I can't say enough about what they can do for a business, and we'll cover that next. Let's pause there to see if we have any questions in the chat window on the data engineering side of things. So if you have anything, fire some questions up. Paul is going to be monitoring. Operators are standing by. We'll just give it a quick pause, and if no one has any questions at this point in time, we'll move on to data consumption.
Doesn't look like we have any questions. So let's move on to consumption.
All right, this is the fun stuff. This is my favorite part. Okay, so on consumption, we have two boxes in there right now. This is where we're moving from data land into human understandable land, basically. We need to shift from a set of tables into a set of business metrics. And I think Paul's going to agree with me. In fact, I don't know if you've seen this slide yet or not, Paul, but I think Paul will agree there's something missing from this flowchart. And that is this thing right here, the metrics layer. The metrics layer is something that we are both very passionate about. This is actually a very new development. There's a few tools that are doing this. Transform.io is one of the bigger names, Supergrain, MetricQL. A few tools are actually doing this metrics layer now. They are either not released yet. They're, Supergrain is still being built as of time of, this presentation. They're not released yet, or they are very, very recently released. So this is a very new part of the stack, but an essential one, because everything that comes out of this metrics layer, what that is a real-time translation between your sort of arbitrarily complex tables and data structure in your data warehouse with consistent human metrics. And so, for example, let's just say you have a metric around total revenue that includes a bunch of factors adjusting for, so you have to do pro forma adjustments for backing tax out of your sales in your transactions table. And you have a bunch of test fields that are, not real transactions, but they're showing up because you use them to test if there's an error in your pipelines, for example. You can apply all those changes, again, as code and script in the metrics layer so that a single metric, sales comes out, and you can ask for sales by any sort of dimension in your data. You can ask for sales by country. You can ask for sales weekly, monthly, whatever. And it will go and do the real-time translation to turn that into the necessary SQL. It understands the structure of the warehouse. It'll turn it into the necessary SQL, make the query, and give you the sort of human-oriented questions that you asked for. Anything you'd want to add to that, Paul?
No, I think that's spot on. And the main benefit here is that at any organization of like a certain level of complexity, it becomes too complicated. Like there's too many, if you join this one table in, you've got to add this other filter for something else. There's too many ad hoc rules that have to happen to be able to accurately get a number. So either one of two things happens. Either you have a layer like this in that means that anyone can just go and ask for sales by acquisition channel and get the right number, or you don't, and then there's only one person who has the institutional knowledge to be able to go and pull that number correctly. And then you have a really big choke point.
And a really important thing to note here is that every single one of the green arrows coming out of the right-hand side of this flowchart goes through the metrics layer. And if every single data consumption tool is using that metrics layer, you have a tremendous benefit of consistency. And I'm sure every sort of CIO, CPO knows that if someone asks for a definition of churn and you go to 13 different groups, you'll probably get 16 different definitions within the organization. And so keeping track of that and having everyone speak the same language pays tremendous dividends in the long run. And we won't even bother going into benefits because you can imagine how important it is to have everyone speaking the same language. You've gone this far to get a single source of truth. The metrics layer is the final piece to achieve that. And that's why it's so important. Now, we have actually, what's happened to date is that we've seen some of the BI tools, for example, build their own internal metrics layers. Most famously, Looker, in fact, is probably the most successful of all the BI tools because of their metrics layer. So they're very good at, they call it the data model, but it's the same thing. It's that translation layer is, Looker's is arguably, I'd say, the best. And I think that's one of the biggest reasons why, they just sold for $2.6 billion to Google. And actually, as of yesterday, I think that they're actually partnering with Tableau, probably the largest of all the BI tools, to provide that metrics layer to Tableau as well. So it's a big deal. Now, the problem with having a metrics layer inside of your BI tool is that only the BI tool can use it. Whereas if you apply a third-party, more generalized one, then it syncs up with every other data consumption tool that you've got, which we're going to get into shortly. So let's jump in a little bit into the BI tool here. Mentioned Looker being the gold standard. What would you say? 2/3 to 3/4 of the companies that we work with, Paul, are probably using Looker. Is that fair? Yeah,
probably closer to 3/4. It's really the default solution. The only reason people don't choose Looker is because it's too expensive, which they normally pay for later in engineering time. So
yeah,
it is by far the most common.
And we would recommend Looker as well if you wanted to save money. We see people using Metabase or Superset, both are popular. Those are open source alternatives, not as good at data modeling, so it'd be important to use a metrics layer, especially with something like Metabase or Superset. The other thing that Looker is good at, by the way, is data exploration too. And some of the BI tools, Tableau is decent at that, but some of the other BI tools are actually not really built around exploration as much as dashboarding. We like to think in terms of sort of modalities of how you consume data, and there's lots of different ways you can do that. The two that you see in BI and Viz here most frequently are dashboards and sort of the ability to write sort of custom explorers, as Looker calls them, or make custom queries and sort of crawl around your data using a point-and-click type interface. Now, there's a lot of other sort of consumption modalities as well, which I think are going to pop up shortly here. One that actually shows up on this BI and Viz list is Mode, which is more of a notebook solution. Writing script in a cloud-based tool and running those on top of your data warehouse. So next up, we're going to take a little bit of time doing customer analytics, the top right, and then we're going to discuss some of those other modalities as well. So customer analytics, we'll come back to that. It's kind of the special niche version of BI tools built for only dealing with event data. It is, there's two big ones, Amplitude Mixpanel. We see Amplitude more commonly. Again, both are good. Ask yourself if you need them. If you're a software-driven business or a very strongly driven business to your website, so for example, some of our e-commerce customers will actually use these quite extensively. Consider customer analytics. If you're not a software business, might not be necessary at all. These are tools that are good at a very certain set of things. So like I said, conversion funnels, a little bit harder to do in traditional BI tools, better in customer analytics. User journey mapping, generally better in customer analytics. Anything you'd also add to that, Paul?
Cohorting usually is easier as well.
Yeah, so that's a great one. Yeah, cohorting better in customer analytics. It's you also see this called product analytics, for example. Valuable tools for certain use cases. For large software organizations, they can also get expensive, but also generally a high value add tool net.
Mm-hmm.
Now, the next important thing to discuss is those other modalities for consumption. And a big part of the modern data stack is that we're moving beyond just BI and visualization as the use for this data. Now that we're centralized and everything, we can do that, which is great. So I'm going to take this old indicative box, and I'm actually going to expand it out to a bunch of other tools. We're going to call BI and Viz General BI down below. And we're going to throw in all this other stuff into, Solutions BI is the name that I gave it on the slide. It doesn't really have a name yet, but it's a set of other things that you can do with your data. I listed 4. I'll bet you Paul can probably think of other ones too. But just going through these one at a time, notebooks and exploration we've mentioned. Notebooks are something that a more advanced analyst can do to write some, generally Python, but could be other languages, and do sort of custom, deeper analytics. You're moving into highly skilled territory there. It takes a good understanding of programming and data to do that, but it's also just arbitrarily powerful. You can do pretty much anything in Python, including writing machine learning code, all the way through to just special visualizations, deeper analytics. You can do pretty much anything. Exploration, I think of as the sort of, the no-code version of that. And that's, point and click, scrolling around stuff. And that's sort of like if you have a dashboard that says, hey, listen, sales are down, and you wanted to go and slice that by something and make a change, you jump into exploration tools to say, okay, I'd like to see my sales by country and by campaign. And using a relatively straightforward sort of point and click GUI, you can, make queries and understand your data beyond your dashboards. Third big use case is sort of monitoring or alerting. This is becoming more sophisticated as we speak, and we're starting to see some tools emerge around that with regards to Zenlytic. Watch this space. This is really important because now that you have this data, it's often too much to go and check across sort of end to end, all the time, because you have too much data now. you've inverted the problem. You have too much information at your fingertips. So monitoring can be set up to say if something important is happening, and you can get very either real time or near real time, or just very high frequency, high resolution sort of alerts or notifications if you have a problem. If let's say Safari pushes an update to iOS on mobile and your checkout button, no longer works, a monitoring days later, you can know about it almost instantaneously. So monitoring is a growing and very important part of data consumption. And the last one is actually reverse ETL. This is also rapidly growing. This is actually the act of reverse API and back into those tools on the bottom left, the third-party platform. So, and people might ask, why would you want to do this? The reason is you can actually get some of that analytics back into the native interfaces that the end user is using them in. The vast majority of reverse ETL right now, I think, happens to one of two destinations. The first one is Salesforce, and the second one is Google Sheets, actually, for sort of spreadsheet type analytics. If we take the Salesforce example, which is I think by far the most common, you can sort of calculate a lead score and put that directly back into the Salesforce interface so that your sales team, when they're actually going and contacting a potential customer, they have that information at their fingertips. And a big part of the whole modern data stack philosophy is making the data available to the people that need it when they need it in the places that they need it. And reverse ETL makes sure that it gets to the right place so it can be consumed by someone without having to jump out to a general BI tool and dig around for it, for example, which in practice, probably isn't going to happen. So, and we can see this sort of myriad set of solutions is coming out. People are consuming data in many different ways. There's a whole bunch of other vertical specific use cases that I haven't mentioned here. So, one of our co-founder, or a portfolio cousin of ours does, ML predictions on user engagement, basically, and automatically pipes that information back into Facebook to inform your ad purchases, for example. More solutions-oriented stuff also comes out of this sort of solutions BI. I'll stop as well, Paul, if you have any other applications that you think it'd be worthwhile to mention here, or any other color on these various tools.
No, those are really the main ones. I'd say the other thing about reverse ETL is sometimes it doesn't make sense at first, but the main thing that you're trying to pipe in is information that you calculated with like all of your data inside of the warehouse, and then you can take that these sort of like enriched metrics. So like you could calculate, expected customer lifetime value, and then pipe that into Salesforce, just to give a concrete example. So you're not just taking that raw data that you got in and putting that raw data back into Salesforce. You're calculating some metrics that help you better serve your customers, and then pipe that into Salesforce or whatever other tool.
Absolutely. All right, we've got about 5 minutes before any other question time. There's one important thing to discuss here. So we've covered the big data portion, we've covered the Toronto portion, and the last part is the AI portion, basically, of the conference. We haven't talked that much yet about machine learning. So machine learning, it's kind of, you'll also notice that I've actually drawn this off of the metrics layer as well, because machine learning can use a lot of those same metrics. For the case of machine learning, sometimes the metrics layer also becomes, sometimes can call it a feature store. But the cool thing about the modern data stack is it's also very good at enabling machine learning, solutions. And this is people that want to build AI applications on top of it for various purposes. And I thought we'd spend a few minutes talking about, what we see in the wild for machine learning and AI, the approach that we'd recommend right now. I would say that machine learning and AI has a very central place, or it connects very nicely to this data stack. But generally speaking, I'd say the best way to do it is not do it. I don't know if you'd agree with that or not, Paul. I'd love to hear your thoughts on it too.
I think usually it depends, but a lot of the times what people really need is just some basic like metrics that they can calculate and act on instead of machine learning. So I think it would be it's important to just evaluate, do you really need machine learning? Like, are you doing fraud prediction or something else that is a very classic like machine learning problem? If you are doing that, then like you probably need machine learning. But if you're trying to just like, better serve customers or like send better emails to people, then you really don't need machine learning.
Yeah, that's my sentence exactly. It's, machine learning has a very important place in a very narrow domain of use cases. And those use cases, several in common, they're things that have to be done at scale. So that have to be done in almost real time and in scale. For example, recommender systems that Netflix is doing. It takes an AI to recommend shows to everyone, for example. And they also have to be sufficiently complex that sort of some simple if statements won't do. And we've, for example, we've done some work around fraud prediction. And you can build an advanced AI for it, but when you go and unpack that using machine learning explainability, quite often it's a couple steps in a tree that determine the vast majority of the predictions of that AI. So you have to ask yourself, is this something we need to do at scale anyways? And if even if it isn't, can we just do this with a few simple, more understandable if then else's, which is kind of the dirty secret of AI right now. The reason why you wouldn't want to use machine learning as well is that there is a pretty, it's got its, there's an entire flowchart now around the growing field of ML ops. So there's a whole other set of tools for sort of building, testing, deploying, maintaining, retraining all of your machine learning models. We're not going to go through all this, don't worry. The point of this slide is to show there's a whole bunch of other tools you need to learn. The interesting thing is that you can see the tools in this flowchart are a lot more overlappy and a lot more murky at this point. That's because the ML ops stack, in my opinion, is not quite as mature as the data stack. So this is being developed actively. That's why, for the reason for the second bullet, if you do it, don't productionize it. That's because it's actually very hard to productionize. Keep your models fresh, keep them from not being fragile, keep them handling edge cases. There's lots of considerations for machine learning production right now. I would say that the vast majority of businesses should crawl before they run. They should be setting up really great data analytics stacks. And by the time that's complete and running and everyone's like, that's delivering tons of value, you can revisit ML ops at that point in time. We'll probably see a bunch of developments in the tool set. We're talking a year or two out. Well, it'll probably be a different picture, and we'll see more certainty in what's happening around ML ops. I even saw, for example, this morning, weights and biases, one of the big ML tools, just raised $100 million, which is kind of neat. So we're seeing some leaders emerge, basically. Until then, get your data stack set up, and we'll even sort of provide an example of that. We have situations where we would go out and build really cool AI algorithms for our users, and one stood out to me, which is like predicting who's going to reply or come back and convert on an email. And they had a list of the people, 1,000 emails they collected from people on the website. Paul and I went and built this really awesome AI that ranked it, and we came back and said, hey, listen, these emails are 35% more likely to convert when you email them, and these ones are less likely to convert. And look at this really awesome AI we built. It's like 80% accurate. And the client looked at us and they were like, well, this is really neat. This is great. But we're going to email all these people anyway. It's like, why don't we just email all of them? And we were like, yeah, I guess you could do that. And their next reaction was like, so this is cool, but what did you do over here? And we kind of showed them the work that went into sort of training that machine learning algorithm. And it's basically, we were like, oh, we just took a bunch of the data and we cleaned it up. We put it into a centralized table so the machine learning algorithm could train on. And they're like, but this centralized data is awesome. We've never had this before. And just having access to that was actually the more important thing. And we're like, yeah, but the really cool AI algorithm, but yeah, but this table is a neat part. So they were most excited just by having a clean centralized source of data, which is basically the modern data stack. And that's the first place that we would start. So our advice, as we can see here, tooling advancing quickly. First do the data stack, revisit this later. And that would be our advice. So focus on big data. Toronto's great. Save the AI for later.
Yeah.
So we're running low on, thank you, sir. All right, so we're running out of time here. We've got a few minutes left. If there are any questions on all of this, I think that's the last slide. We'll go back and throw this one back up here. in case there's any questions on this. Questions on AI, questions on the stack, questions on anything. So we'll pause there to see if there's anything. We'll throw open the floor, and we'll wrap up after anyone's had a chance to ask any questions.